Now let's come back to the class and talk about smart house, which is another important aspect of smart grid. So now we have been seeing the penetration of network embedded systems in more appliances. So it transformed the resident infrastructure to an IoT-enabled one and connect to the smart grid. As we can see in the next slide, so the intelligent devices, their behaviors will be actively communicated, maybe basically monitored via network interfaces, as well as adjusted or controlled via interactions or an energy management system or other service providers. So all this network energy consuming and or producing devices exponentially expands the IoT infrastructure and now an active participant in energy management efforts. So basically what's happening now is like this. So basically for the appliance in the house, in the fridge, the washing machine, the heating cooler, there's the AC, and basically especially for these few guys, they consume a lot of energy. Now they are empowered with the IoT technology. Basically, they can be connected to the internet. It promotes the internet and the IoT interactions for energy management. A typical example to comprehend the significance of IoT in residential infrastructure is the following. So for during the summer, so sometimes there is a shortage of power generation. So previously, the grid operator will contact heavyweight energy consumers like factories to ask them to reduce their load. But the blackouts are still occurring and costly for all stakeholders, not only the factories, but also the residential consumers. On the other hand, this can clearly be done only with. On the other hand, we can also refer to the residential consumers to see what we can do. Basically, if the energy peaks from the residential consumers can be reduced or shifted, it will greatly ease energy management and make it more efficient. Basically, if we can, by using some high-level data analytics and optimization, we can reduce the usage of power from the residential areas, or we shift the peaks from the factories away from the residential area, then we can make our life better, easier. So in the above scenario, instead of contacting only a limited number of industrial consumers, now thousands of residential consumers can be contacted and assisted by adjusting their energy consumption. So for example, all unnecessary devices could be turned off. The key message here is that similar results cannot be achieved on a larger scale if a critical mass of residential consumers can be reached. So that's a vision for the smart grid and the smart house. So several research projects focus on the integration of smart house and its appliance into the smart grid. It's now happening. One example is the smart house smart grid. It's in the reference. So it is shown here in this slide. So we have a location A, location B, location C, location X, and the network enterprise service are connected to all the residential areas, and value-added services will be provided there. For example, how to energy consumption during the day, together with the ERP, and also the customer relationship management system here. So the idea is that thanks to the data and interaction enabled by the IoT technology, so the optimization and the management can be in the whole to reach the best results to satisfy the requirements of different stakeholders. So of course, during this process, it is not a one-size-fits-all approach. There can be many and diverse approaches, and system integration will be a key issue in phase from such solutions can be delivered. For this smart house smart grid project, it builds on the following elements. It includes the engagement based on user feedback, real-time interface, And also it has the aggregation software architecture based on the agent technology, service delivery, and it also have the usage of service-oriented architecture. We discussed this SOA in the last unit, and also a strong bidirectional coupling. So within household appliance devices are integrated via some form of gateway concentrator that connects the smart grid. So usually it is not common for one to directly connect to the business application. So usually there will be a gateway or concentrators. Basically, it organizes the appliance in-house as a whole. Of course, it can still distinguish it. Washing machine or a fridge. It is a gateway or a concentrator for the appliance in the whole house, and it will connect to the smart grid to provide the information needed, as well as enable the required interactions. By doing so, it not only represent different technical integration approaches, but also different modes of management. Basically, if you use different methods to integrate, so the management can be different. So we have two examples. So one way to do is to use the gateway to connect with the enterprise systems. So easing the management. And the other way is to use the delegation method. Basically, we have some agents that has intelligence and make decisions near the actual infrastructure. So this is actually quite similar to the cloud computing and the edge computing. So if all the processing, computing, management is conducted on the cloud, maybe in the enterprise systems, so it is cloud computing, right? So if it is, I think locally or close to the sensors, close to the appliance, so it will be more close to the edge computing. So what is also required for viable business cases with respect to smart houses as part of the smart grid is the integration of in-house services with enterprise services. So for the enterprise level services, we will have the business B2C and B2B services. So B2C is the sustainable building. For the B2B, with the integration among different players. For example, the energy retailer and home market. For the in-house services, so it will be pretty simple. If we detect, one example is that if it detects via some sensors in your house, if we detect no people are at home, basically it may turn off a majority of the lights in the house, right? So by implementing smart metering, smart house, the ultimate goal or the ultimate outcome of smart grid city, if we emphasize the electricity part, so it is smart grid city. So for smart city, it will be a future topic, maybe next week. But for the smart grid city, so it is expected to empower better and tackling of energy related issues. So some examples of this direction is monitoring applications can offer real-time view on a city's KPI, such as CO2 footprint, energy consumption increase, and penetration of new renewables. For example, citizens can now be able to calculate the smart apps the environmental impact of their in-city travel options. So nowadays, people may not pay attention to this, whether they should take a metro or drive themselves. But in the future, who knows? So monitoring, as well as being able to exercise control capabilities. Actually, these two keywords are also the keywords for IoT, right? What do we do with IoT? So we need to know the situation, which is monitoring. We need to change the situation, change the status, that's control. So they are interrelated. So monitoring and control plays an pivotal role in order to play an important role. Yeah, let's say that. Once this is reality on a large scale, new innovation applications that depend on IoT data as well as their control capabilities can be realized and will impact on individual citizens as well as citywide impact, as shown in this figure. So for individual consumers, the impact can be reflected via the smart houses, smart grid, neighborhood, whatever they want to call. And for the city, if you consider a city life, or to be a person, or to be an entity, so there are many aspects can be optimized. If the energy consumption of the city as a whole are known, one example we'll mention is the Nobel project. It deals with integrating information from various energy aspects of the city infrastructure, including producers, the consumer, as well as the public light infrastructure. Some more details. So to be able to provide value-added energy services, an integration and energy management system, the IEM, was created by using the IOV4 and IPOV-I. Basically, this is very typical internet things, right? As we mentioned, IPv4 and IPv6, they are the IP address to allocate the different entities in the network so that we can access data, we can do math, we can acquire the services we need. So we have an architecture for the IEM. If you are interested in this, you can do more, look into more details, but it's not mandatory. So the IEM itself and several applications depending on it has been extensively tested and used operationally maybe almost 10 years ago with the help of smart meters, of course. So as we can see in the figure, so we can distinguish the following key functionalities that can be offered. So we can have the energy monitoring, energy prediction. So that's where the data analytics come into play, right? And also management for handling the assets, operation issues, and in the infrastructure. So basically, for example, when you should take a shower, so that you can save more energy, right? And also energy optimization. This is especially important for a larger area. For example, for the city, because for your case, changing the time to take a shower may just affect maybe $1 a day. But for the city level, if it's the whole city, if everyone change their behaviors and how to save, for example, $10 per day, then the daily saving of the whole city or the yearly saving can be very phenomenal, right? And also, it will for the system to work, it also need to have the breakage. Basically, offering trading to all customer citizens, just like the stock broker, right? And also, building is always needed, and there are other opportunities for value-added services. So when I was looking at this, so I think that some future services and applications are not fully explored yet. So it may come into one of you in the future. Basically, that means that there are a large number of opportunities. As we mentioned, the Nobel project was implemented quite a while ago. It reveals several benefits for smart grid cities, as well as several aspects to be considered. First of all, it is a must. So, and the needs of the various stakeholders need to be considered, especially when they intersect. So, open services means that every quality play a role can provide services or play a role there. So it is not a closed system. So if it is closed system, so new players will not be able to join. So that will limit the potential of the layout. And also with so many smart meters, with so many gateway, with so many smart houses and smart traffic lights, for example, we will come to the topic of big data, especially IoT big data again, because you can imagine there are many data. So we need to properly process the outcome and also look into their quality and timely acquisition so that we can make decisions timely and correctly. Once the capability to collect citywide data and run queries on them is available, new capabilities towards decision making will come into place. The data is not collected in a central place, but with distributed queries and analytics. So that's what has been done from another project called the Smart Kai, project. So it is illustrated here. Basically, so to conclude, so IoT and iOS, do you still remember what iOS is? It's Internet of Services, coupled with smart grid, a very powerful combination. By properly implementing smart metering and then smart house, we will move towards the smart city level in terms of the electricity supply. And then there are still many challenges to be addressed. So we listed some here. Okay, that's for this video on the smart grid. So in the next video, we talk about commercial building automation.